All right, so if we're on limits, just a quick overview. This is what we did last Wednesday. If I give you some sort of graph, let's say it looks like that. We call this some function, right? And I'm just gonna give these. Just some general values and make this up as we go. What is the limit as x approaches 1 of f of x? Coming into 1, right here's the x value. We're coming towards that x value. What's my y value going to be? Yeah, 2, right? Okay. Nice continuous function. There's no break, no holes, nothing of that nature. So it's just, what is that? We can also say that the value of the function is 2 as well, right? So 1, 2 is this point. Yeah? So that was one situation we ran into. About the limit as x approaches 3. We're coming in here. What's my y value? Yeah, 3-ish, right? My graph is not perfect. So again, this illustrates the point that a limit is where you're going, not where you land. Okay. In this case, what is f of 3? It's this point here, right? So what, 2.5-ish? Starting to re-energize this brain cells a little bit here. And we've got one more situation that we talked about. The limit as x approaches 5. The limit
is
can have a whole. Okay, the limit is 2. Okay, because we're just going to this point. And that y value is 2. That's where we're going. Right? So that's okay. Right, this is where people trip up on limits. What is f of 5? Yeah, it does not exist, or it's undefined, whatever you want to stop it. So 3 situations that you can run into. There are a couple others that I'm not going to show you yet with asymptotes, infinite limits, but that's what we looked at Wednesday, right? Okay, today, the number one method, so this was a graphical representation. Let's talk about algebraic manipulations. Okay. It's definitely example 4 in section 15.1. There it is. Let's check this one out. Limit x approaches 4, x squared minus 2x minus 8. When you see one of these, what's your first attempt? give up, go in fear, you're done. Right? It's pride. As somebody called me yesterday, you're pride. Yeah, plug and chug. That's number one, right? Plug and chug. So if I plug 4 in, what do I get? Okay. Something. Oh, okay. Excuse me. Uh-oh. Anybody know the answer to that?
Infinity.
No. This is called an indeterminate form. Okay. Because what is 0 things divided 0 ways? Okay. So remember your fractions. 0 over, let's say, 2 is 0, correct? Remember that? Okay. 2 over 0 is undefined. Those you know, but those 0 over zeros, oh. It's called an indeterminate form. So we're going to use algebra to manipulate this, probably. So our next attempt is to try some algebra. So can I do anything with that? There. Okay, on the bottom, it's called what? Factoring. Can I factor the top? And it is. Try to keep your work nice and organized. So every time you rewrite it, yeah, it's a pain in the butt, but writing the limit again is mathematically correct, but it also keeps you organized. Okay. Oh man, hallelujah. Guess what? Bye-bye. Now we have that left over. I plug and chug again, and we get do the math. We got plug and chug gives you an indeterminate form. Try to factor it. Then plug and chug again, you might get an answer. But basically what you've done here is it's this situation. There's a hole in the graph. You've taken the hole away. Graph. You've basically taken the factor out that causes that to happen. So there you go. All right. I'll show you one more, and we'll be good. Oh, that's not what I wanted to write. H. Another difficult to do the problem.
Let's say,
All right. Okay, plug and chug. Always try it first. Yeah, we get 0 and 0, right? We have an indeterminate form. Now what do you try? What can you take out? Bottom's already H. Hallelujah, that makes it easy. Take an H out of the top. Right? Goodbye. And we plug and chug now, and what do we get? got graphical limits in your melons, you've got plug and chug, and now you've got algebraic manipulations, okay, at a basic level. Pretty straightforward, bit?
This is the base for calculus.
Yeah. I'm gonna go ahead and say my printout didn't come out of the printer without my help. I didn't do it. Yeah, limits define derivatives and integrals, which are the two big topics in calculus. Okay.
Yeah, Mr. Arthur was graphical.
And then wait.
Graphical?
Yeah.
That would be these. You look at the graph and solve it. So here, okay, 15.1, 7, 8, 10. Oh, that is terrible. 19 through 22. I used to be really good with a railgun, I swear. About 3 people understood what I just said. Okay, this is due tomorrow. If you want to start on it, the spiraling, whoops, should not be a comma. And then we could just go on into today, but this is not going to be due until Friday. I'll add a little bit to the spiraling tomorrow. But if you want to get a head start on it, have at it. But make sure this is done. Okay?